Hello, everyone, and welcome. Today, we are diving into a journey that transforms a simple spark of curiosity into a powerful piece of scientific work. We're talking about the art of scientific research writing, taking you from the initial idea all the way to making a real impact, whether you're a student starting your first project or a seasoned researcher looking to refine your process. This guide is for you. We're going from idea to impact, and it all starts with one crucial first step. Let's get into it. So, where do you begin? It all starts with choosing your topic, and the best way to do that is to start with questions. First things first, where do great research ideas come from? They start with questions. Seriously, it's that simple. Look around your field of study. Think about your field of study. What genuinely fascinates you? When you're reading textbooks or attending lectures, what are the things that make you go, I wonder why that is? Pay attention to those moments of curiosity. What problems do you see around you, either in the lab, in the community, or in the existing literature? What problems or inconsistencies do you notice? The goal here is to find a question that hasn't been clearly answered yet. It could be a new angle on an old problem or applying a known method to a new context. Maybe you've read a paper and thought, but what about? That's your starting point. The best research often springs from a deep-seated curiosity. Think about a question that hasn't been clearly answered before. That's your opportunity to contribute something new. A good acid test is to ask yourself, can I pose a question that no one has definitively answered before? A successful scientific paper always begins with a compelling research question. This question should emerge from genuine curiosity and a thorough understanding of existing literature. Effective questions are specific, original, and answerable within the constraints of your resources. Ask yourself, what problem do I want to solve? And why does it matter? Of course, passion alone isn't enough. Your topic needs to be practical. Does it align with the requirements of your course, the focus of your department, or the scope of the journal you're aiming for? A brilliant idea that doesn't fit the context is like a key for the wrong lock. So before you get too attached, do a quick reality check. Make sure your topic is relevant and feasible within your given constraints. This initial alignment will save you a lot of headaches down the road. Once you have a general idea, it's time to become a detective. This is the literature review phase. Why is this so crucial? The purpose of a literature review is to understand what's already known about your topic, because you can't build on existing knowledge if you don't know what that knowledge is. The goal here is to understand what's already been discovered, how it was discovered, and most importantly, where the gaps are. These gaps are the sweet spots where your research can make its mark. Before embarking on your research, conduct a structured review of relevant literature. This helps you identify the gaps, the unanswered questions where your research can make a real contribution. This involves identifying key studies, understanding existing methodologies, and recognizing areas where knowledge is lacking. By synthesizing prior work, you clarify your research's novelty and relevance. Without a thorough review, you risk wasting time researching something that's already been solved. So, where do you start digging? Academic databases are your best friends. Google Scholar is a fantastic and accessible starting point for everyone. You can also use more specialized databases like PubMed for life sciences, IEE's Plore for engineering, or JSTOR for humanities and social sciences. Type in keywords related to your topic and see what comes up. Don't be afraid to try different combinations of search terms. As you start finding articles, the real work begins. Don't just skim them. Read them critically. Take detailed notes. Ask yourself, what was the main finding of this paper? What methods did the authors use to get there? What were their limitations? Pay close attention to the discussion and conclusion sections, as authors often point out the limitations of their own work or suggest areas for future research, and most importantly, what questions did they leave unanswered? These open questions are gold mines for your own research. Keeping your findings organized is non-negotiable. If you just read a dozen papers, their ideas will blur together into an unhelpful mess. Create a system that works for you. Some people love spreadsheets, creating columns for the author, year, main finding, methodology, and notes. Others prefer mind maps or simple summary documents. The tool doesn't matter as much as the habit. This organized summary will become the backbone of your introduction and justification for your research. By organizing your notes, you'll start to see patterns, debates, and you guessed it, those precious gaps in the research. This process directly feeds into the next, most crucial step, formulating your research question. Now, with a solid understanding of the existing literature, you're ready to sharpen your focus and formulate a powerful research question. This isn't just a topic. It's the specific guiding question that your entire project will be dedicated to answering. A vague question leads to vague research. Your question needs to be specific, original, and measurable. Specific means it's not too broad. How does climate change affect plants? Is too big. A more specific question would be, how does a 2 degrees Celsius increase in average temperature affect the flowering time of the cherry blossom tree? See the difference? A great framework to use is the who, what, where, when, why, and how approach. Let's break it down. Instead of a broad topic like enzyme activity, a good research question drills down. For example, how does temperature affect the activity of the enzyme amylase in yeast? Let's analyze this. How points to the mechanism. Temperature is the specific variable you're testing. Amylase is the specific enzyme, and in yeast defines the organism. See how specific that is? It's a question you can actually design an experiment to answer. Your question should be a clear, concise statement that guides your entire project. With your crystal clear research question in hand, it's time for the planning phase. This is where you become the architect of your study. You need to decide on your research methodology. Are you going to be in a lab running experiments? Will you be creating and distributing surveys to a specific population? Perhaps you'll be doing fieldwork, observing subjects in their natural environment, or maybe your research involves analyzing existing datasets. Original means it builds upon the existing literature to explore something new, filling one of those gaps you identified, and measurable means you can actually collect data to answer it. Think about your topic and try to frame it using these words. For example, instead of just enzyme activity, you could ask, how does temperature the how affect the activity of the enzyme catalase, the what in bakeries, yeast, the who? This question is specific, it's measurable through experiments, and assuming you did your literature review, it's original. Now that you have your powerful research question, it's time to plan how you're going to answer it. This is the planning and conducting phase. The first big decision is your overall approach. Your choice of methodology must be the most appropriate one to answer your specific research question. If your question is about how something works at a molecular level, experiments are likely your path. If you want to understand why a certain group of people behaves a certain way, surveys or interviews might be more appropriate. Once you've decided on your approach, you need to select the specific methods and tools. Choose the tools and techniques that will give you the most accurate and reliable data to answer your question. If you're doing experiments, what equipment will you need? What variables will you control and which will you measure? If you're doing a survey, how will you design your questions to avoid bias? What platform will you use to distribute it? This is the stage where you create your detailed blueprint, write down a step-by-step procedure, think about potential challenges and how you might overcome them, and finally, a critical component of any research plan is ethics. Research doesn't happen in a vacuum. It often involves people, animals, or sensitive data. It is your absolute responsibility to conduct your work ethically. This means getting the necessary permissions from an institutional review board or ethics committee if your study involves human or animal subjects. Research isn't a free-for-all if you're working with human participants. You'll likely need to get approval from an institutional review board or IRB. This involves ensuring informed consent and protecting participant privacy. If you're working with animals, you must follow strict guidelines for their care and treatment. Even if you're just analyzing data, you need to consider issues of data privacy and proper citation to avoid plagiarism. It means ensuring informed consent, protecting Participant privacy and handling data responsibly, upholding ethical standards is not just a box to tick. It's the foundation of credible and trustworthy science. Always put ethics at the forefront of your planning. Getting the necessary permissions and following ethical protocols is non-negotiable and protects both you and the integrity of your research. So to recap, we've gone from a flicker of an idea to a fully fledged research plan. Okay, let's fast forward. You've conducted your research and you have your data. Now what? You have to write the paper. You've chosen a topic, scoured the literature, crafted a precise research question, and outlined your methodology with ethics in mind. The standard structure of a scientific paper is often referred to as IMRAD: Introduction, Methods, Results, and Discussion. This groundwork is the most critical part of the entire process. A strong foundation makes building the rest of your paper, the introduction, methods, results, and discussion, so much easier. Let's outline what goes into each section. The introduction sets the stage. It starts broad by introducing the general topic and its importance. Then you'll summarize the key findings from your literature review, highlighting that all-important gap in the research. The intro culminates with your clear, concise research question and often a brief statement of your hypothesis. It tells the reader what you did and why you did it. Next up is the methods section. This is the how-to manual of your study. Your goal here is to provide enough detail so that another researcher could, in theory, replicate your study exactly. You should describe your participants or materials, the equipment you used, and the step-by-step procedures you followed. If you used any statistical analysis, you describe them here as well. This section is all about transparency and reproducibility, which are cornerstones of good science. After the methods comes the results section. This is where you present your findings and only your findings. It's the what you found part of the paper. You'll use text, tables, and figures to present your data clearly and logically. For example, you might say, as shown in Figure 1, the enzyme activity increased with temperature up to 40 degrees Celsius, after which it rapidly declined. The key here is to report the results objectively without interpretation or explanation. Just the facts. The why comes next. Finally, we have the discussion section. This is where you get to interpret your results and tell the reader what it all means. You'll start by summarizing your main findings and stating whether they support your original hypothesis. Then you'll compare your results to the findings of other studies. From your literature review, are your findings consistent with previous work or do they contradict it? Why might that be? This is where you truly engage with the scientific conversation. You should also acknowledge the limitations of your study. No research is perfect and suggest directions for future research. The discussion section concludes by circling back to the bigger picture, explaining the broader implications and impact of your work. It might seem like a lot, but by breaking it down into these manageable steps, you can tackle any research project with confidence. Thank you so much for joining me today. I hope this has clarified the initial and arguably most important steps in the scientific writing process. If you found this helpful, please give this video a thumbs up. And don't forget to subscribe for more content on mastering research and academic writing. If you have any questions, drop them in the comments below. I love hearing from you. I'll see you in the next video.